Hello everyone, this is group number 19. Our topic is predicting cryptocurrency stock prices in near term. I am Mohit Mahajan. In next slide I will explain the problem statement. So we are given with the time series data for various crypto assets such as Bitcoin, Ether, Dogecoin, etc. Our goal is to predict the future prices so as to make some profit from the trade that we will execute. Then we are having data set. We are given with information about the various cryptocurrency asset that there are total 16 different asset in our data set with various label as follows. First is the timestamp. The timestamp is 1 minute in our case. Then there is asset id to identify each asset. count Count is the number of trade took place at that minute. Open is the opening price of the asset in that candle. High is the high price achieved by the crypto coin in that minute. Low is the lowest price achieved by that crypto coin. And close is the closing price at the end of the minute. Volume is the volume of the crypto asset traded at that minute. uh, VWAP is the volume weighted average price for that minute. And the last one is target, which is 15-minute residual returns.
Hello everyone, my name is Shashank Dwivedi and my roll number is B21023. This is one of the models that our team has made to find the future price of the cryptocurrency. Here, my model approach is auto regression. So first we will find the percentage change of the cryptocurrency prices and then we will apply auto regression on it. This will provide us the predicted percentage change from which we can find the predicted closing price of the cryptocurrency. So what is auto regression? Autoregression is a time series model that uses observation from the previous time steps as input to a regression equation to predict the value at the next time step. The process is basically a linear regression of variable performance in the current time series against the past performance of one or more variable in the same series. So why only autoregression? In autoregression, the autocorrelation function can be used to tell whether there is lack of randomness or not. Secondly, the ability to forecast recurring patterns provide it a good edge. Third thing is less amount of variables are required to give a good outcome, so a self variable series can be used to foretell the outcome. So let's start with the model. Here we have imported all the libraries required to make an auto regression model. So first we will import a CSV and store it in a variable. Here, as a database contains information of many coins, so we will select only one cryptocurrency. Here, I have chosen Ethereum, which have an asset ID as 6 in our database. Now, I will divide the database into train data and test data. Here, I have chosen percentage change as the most important data and applied auto regression on that. Why I have done so? Here is the answer. So first we will go through percentage change. Percentage change is basically the final value minus initial value upon initial value into 100. The same can be applied for the percentage change for the cryptocurrency. So why only percentage change? Percentage change is used to track the change in quantity over time. It shows the contribution of both the values, that is open and close prices. Percentage change also provide us information about how much the thing is varied. So here this is the application of auto regression and all the calculation which I have included in a function named model, which takes input as lag value, train data and test data. So here I to find the accurate model and the least RMSE, I ran the model for lag value till 20, and for 20 I found the least RMSE. So here you can see the RMSE for percentage change and for the closing value of the cryptocurrency. So here RMSE for percentage change is 0.0003, and for the close value it and for the close value for lag value as 20, it is 0.0598. So here are some graphs which shows relation between the predicted and the real values. And this is the final graph which shows the real and predicted close values, where real value is in green color and predicted value is in red color. Thank you.
Hello everyone, this is Aman Kumar Mahanti, roll number B21036, would now represent the polynomial autoregression model. Here we are using polynomial regression model, but we are taking inputs as time lag values, therefore it is polynomial autoregression model. As we can see here, the CSV data that we took consists of around 24 million tuple with different asset ID and close value. There are different crypto coins with different asset ID, but here we are taking close value of Ethereum as the asset ID of Ethereum in the sheet dataset is 6. Now we are converting the data of Ethereum into a data frame. As we know that the data is too large to be operated upon, we are reducing the data set to 50,000 tuples and then we split the data into training and testing data without shuffling. Now we are taking 50 lag values of the close of Ethereum in the dataset and storing in the data frame cry6df in order to operate polynomial autoregression model. Here you can see the lag data values but there lies a problem. The problem is that there are 50 initial NaN values which needs to be dropped off so that it does not affect the output. Now we just put the training data and testing data in this model in order to find the next 15,000 data values of close of Ethereum. We now use p-value of 2 in order to find the predicted data set of next 15,000 data set. Now we see the outputs of the actual next 50,000 results and the predicted next 15,000 outputs, which shows an MSE error of 2.12. Thank you.
So we have made our 4 models in cryptocurrency prediction, out of which the last 2 models are made using the LSTM. We have made this model using LSTM, and the 2 models are used, one in PyTorch library and the second is using the TensorFlow library in Python. The brief introduction about LSTM: that LSTM is a long short-term memory. It is an artificial neural network used in the fields of artificial intelligence and deep learning. In standard feed-forward neural network, there was a drawback, that it does not have the feedback connections. But in LSTM model, the feedback connections are there. Such a recurrent neural network can process entire sequence of data rather than processing only single data points in the LSTM model. The name LSTM itself refers that it has a long-term memory and a short-term memory also. I have made my contribution in the model made using the TensorFlow library. So I am going to briefly introduce the TensorFlow model using TensorFlow. As LSTM networks are well suited to classifying processes and making predictions based on time series data, we have used it to make predictions in our data using Rayleigh activation function. Here we are provided with our data of 13 coins, which is too huge data to process, and it will take too much of training time. So we made our model only on one coin, which is Bitcoin. Also, we are provided with 6 independent attributes of each coin, which will also take the lot of training time. So we have reduced the data and used only one attribute of low price to predict the cryptocurrency price. The motivation behind choosing this independent attribute is that it is most correlated with the attribute to be predicted of given all attributes. And you giving a brief idea about our model, the attribute value size, the data size in each attribute is nearly 19 lakh in our data, which is per second given. So we have made our timestamp per day using the group by function, so it should be reduced. And next we have made the last 60 days data use and predicted the next day data in our model.
So myself Ravi, my roll number is B21132. As Shantanu explained you all in brief about the LSTM model and how it works, let's deep dive into the methodology used. First of all, we try to find the correlation of minute, hour, daily and weekly and monthly time lag and plotting them on a graph to know how much correlated each time lag is, as these are used in the future calculation. So while looking at the graph, we can see that 1 minute time lag is the best, but using that time lag in data is not feasible as it will take too much time. So we choose daily time lag data. After that, we divide the data in X train and X test. So as last 60-day values are used as test data and remaining as training data, in this train test split we divide data into window size of 5. This window size will be used as one batch. After that uh, as we are using TensorFlow, 3D input is required in the format of batch size, timestamp and features. In this case, we have a batch size of 200, timestamp of 5 days and feature 1 that is closing price. We build the model using 3 layers and a dropout layer at each level to avoid the overfitting. Reduce the activation function use. Return sequence is said to be true means that data will be in same shape after the second layer as first layer output will be input for the second layer. Total 1,16,000 parameters are generated in this model. Here comes the final training model part. Loss function is calculated and all the weights and biases are adjusted for each training data. A file name checkpoint path will be created and that will be stored. Once loss does not changes, the epoch model will be terminated and last checkpoint will be used. Finally, we predict the values for next 60 days and as you can see that the prediction data resembles the training data but there is some error. As cryptocurrency market is highly randomized and volatile, sometimes even factors such as news play important role rather than those factors considered in this project. Thus, final conclusion is that more complex model using language recognition can also be used as an attribute so that more precise and highly correlated model can be built. That's all from my side. Thank you.
Hello, my name is Aman and I have created the LSTM model in PyTorch. So our previous LSTM model uses only one feature as data to the model. However, we can do much better if we can use multiple features for the training of our model. I made this model using the PyTorch library, which provides us with quick and easy to use API for programming our model structure. For our features, we are using high, low, open and close prices as these features are deemed most important for the prediction. Here we are predicting the high value as we need to predict the maximum expected value of the coin in the near future for making the most profit. So first we load the coin details and then load the data for any one coin from our selection. Here we are choosing Ethereum. Now is the time to pre-process our data before sending it to the model. So we are using a min-max scaler which will scale our values from 0 to 1. Scaling our data gives us better results and helps prevent bias of one feature. We have loaded a total of 2 lakh values for Ethereum out of the dataset which contains 2 crore values. Here we are designing our model. Designing the model takes several iterations and it is based on experimentation. But we are using 4 input parameters, 3 LSTM layers and a single cell output layer for our regression model. We initialize our model with one input layer of dimension 4, 3 LSTM layers of dimension 128 and one output layer of dimension 1. Now let's train our model using our pre-processed data. We are using 500 epochs to train our model and we are using only the initial 15,000 values due to limitations with the VRAM of the GPU. So after training, we can see that our mean squared error drops from 0.32 to 0.019 in 500 epochs. Now we can predict the values using our trained model. We are predicting the 10,000 values after the training data due to limitations. So here is the graph of the 10,000 values after our training data. We can see that the prediction gets more accurate as we provide more data to the model, which is a property of the LSTM model, which works very well on time series data. Thank you.